Right, everyone, let's go ahead and get started on this second homework assignment. The polygon below are similar. The figure on the left was reduced to create the polygon on the right. What is the scale factor? All right, so find the length of the missing sides. Okay, so to do that, you're going to need to, so the figure on the left was reduced. So the right is the image and the left was the pre-image, right? So the resulting is the left side, the resulting is the right side. And it was originally the left. So in order for us to create to find the scale factor, we need to take the final result and take the corresponding side. So this little side right here is going to correspond to this little side here, and we need to divide 4 over 6. All right. So the scale factor is going to be 4 over 6, or if we reduce each of these by 2, we get 2 over 3. So that's our scale factor. So scale factor is 2 over 3. I'm going to use that to help us solve for the missing information, right? And remember, we started with the small side first, and then we went to the bigger side, from the smaller shape to the bigger shape. So if we want to find, let's say, that side, so that's 6. So we would need to start with 6 over, and then we need to go to the larger shape, which is the x. So 6 over x, and that's going to be equal to 2 over 3. Okay, do a cross multiplication. 2x equals 6 times 3 is 18. Divided by 2. X equals 9. So that side right there, that's going to be now going to have a length of 9. Okay. One more side. Let's say, well, 2 more sides. We got y right here. So we'll rewrite that as y over, and this side right here, 12. And remember, we're going from the smaller to the bigger one. So y over 12 is equal, and then our scale factor is 2, which is a smaller one, and then 3, which is the bigger one. Right? So again, do a cross multiply. 3y equals 2 times 12 is 36. Divided by 3. Cross cancel and reduce it, and y equals 12. So that means that y is going to be, is that right? Oh, I did the math wrong. I was like, that cannot be 12 also. I mean, because this is already 12. Right? So where did I go wrong? Right? Let's go back. Backtrack. So I went and did y times 3 is 3y, and 2 times 12 is not 36. That was my bad. So y times 3 is 3y equals, and then 2 times 12 is 24. There we go. I said 36. Okay, divided by 3, cancel, and y equals 8. So that means that the y, this smaller green side, is 8. Okay, and let's do the last one. And then we got z. So we'll write here z over 5.7. We might need a calculator for this. And that's going to equal our scale factor, which is 2 to 3. All right, so you're going to go ahead and do the cross multiplication. So 3z equals, and 2 times 5.7. I'm going to pull up my calculator. So 2 times 5.7, that gets me 11.4. So 3z equals 11.4. Then we're going to go ahead and divide it by 3. We get z equals, so 11.4 divided by 3. So I'm just going to hit divide 3. We get 3.8. So that's 5.7. Then that means that this is going to be 3. 3.8. Right, so we found the length of Z, we found the length of X, which is in blue, Z is in purple, and we found the length of Y, which is in green. So you can write down, right? You can write down X. So scale factor, X equals 9 from that work. Y was green. Y equals 8. And Z equals 3.8. Okay, so all right, the two triangles below are congruent. Write a congruent statement relating the triangles. Describe the sequence of transformation that maps one onto the other. Right, so if they are congruent, right, what you need to do is, if you have a piece of patty paper, you need to make them look exactly the same, or at least in the same direction. So if I'm doing this, okay, and I'm going to go ahead and label this HAN. Okay. Now I'm going to go ahead and I'm going to try to do my transformation, right? So my sequence of transformation. So first, I think I'm going to go ahead and I'm just going to go ahead and flip this, right? Or reflect this across the y-axis. So I'm going to flip it left and right, right? So if I flip it left and right, you can see that it already matches it. See that? And then if I just move it, so I went and did first I went, so my transformation is I went and reflect across the y-axis. Y-axis, remember, y-axis looks like this. So I would flip that across it. So this goes across. So that's what happened. And then I would translate to the right. Okay. And that's where I would be at. So, and because I flipped it across, okay, my numbers look a little different. A looks okay. H looks okay, but N is totally backwards. So, but I know that's N, right? So when I go and write my, so that was the describe the sequence of transformation. Now I'm going to go ahead and write a congruent statement. So notice where each of these are the letters are. Okay. So J and H are in the same spot because I did the transformation. A and O are in the same spot. And N is backwards, but it's N, and E are in the same spot. So when I write it down, I have to write it in the same order. All right. So I'm going to go ahead and start with J to O to E. Okay. And you can go any order you want, but I'm just going to go ahead and do that. J-O-E. So I'm going to say triangle J-O-E is congruent to triangle. And then I'm going to use the same order. H to A to N. And it has to be in the same order. To triangle H-A-N. Okay? As long as you go in the same order, it doesn't matter which letters that you put first, second, or third. Right? So another example, I could have went and done. Okay, we'll do one more. Okay, I'll use dark or light green. Okay, so I could have went and did angle O to J E. Right, so I could say triangle O J E. Right, so you see how it's that order. I have to go in the same order. So it's congruent to triangle A to H to N. See how the arrows are in the same order. So A, H, N. Okay. And there's different ways you can do it, but this is just two different ones. Right. So that's my congruent statement. All right. Number 21. Let's see. Solve the system of equations below using method of your choice. If there is not a solution, explain why. Right. So since this is already set up and they're both equal to y, I can either graph it or I can do a equal values method. And because these are equal to each other, I'm just going to go ahead and do equal values method. So I'm going to say that the top equation, which is negative 2/5 x plus 1, that's going to equal negative 2/5 x minus 2. Okay. And by doing this, I can go ahead and add the x's together. So I'm going to add 2/5 x to the other side. Okay, which is going to cancel these out. And these also cancel out. We didn't intend for that, but it just happens. And we're going to end up with 1 is going to equal negative 2. And you see how we don't have any more x's? That means that we're at a point where we have to kind of figure out what's going on. Okay. So this equation is 1. It says 1 equals negative 2. And that is what we call a false statement. That's never true. Right. And because it's a false statement, then that means that there is going to be no solution. Okay. That's all it is. All right, let's get to the last one. So you might need graph paper. I'm going to go ahead and make my own. And then I want you to graph triangle ABC. All right, so I'm going to go ahead and graph triangle ABC here. So I'm just going to go ahead and make my own graph.
Okay, doctor, there's a student that needs to leave and he's parked on the blacktop. Are you able to unlock the gate?
So A is negative 2. And 7. Joe.
The blacktop by the baseball field.
1, 2, 4. Okay, I'll go over there. 6. So that's where A is. A is at 2 or negative 2 and 7. So right there, so negative 2 and 7. So I'm going to go ahead and put my point A right there. And B is at negative 5. And 8. Oh, that's a little higher up. So B is negative 5 and 8. And 8 is a little bit higher up, so I'm going to go ahead and extend this out just a little bit. So that's 7. 8 is one more higher. Oops. So that's negative 5 and then 8. That's B. And then C, I'll put that in green. C is going to be negative 3 and 1. So negative 3 and 1 is about right here. And that's okay. So that's triangle. I'll put it in purple. A to B to C. Okay. So reflect triangle ABC across the x-axis to form A prime, B prime, C prime. Name the coordinates of each new vertex. Okay, so I might need some extra space. All right. So let's go down a little bit. All right. And if this goes all the way up to positive 8, I might need to go all the way down to negative 8. Okay, so I've got negative 1, 2, 3, 4, 5, 6, 7, 8. So you see how C is 1 unit away, and so part A, they want us to reflect this across the x-axis. Right, the x-axis is sitting right here. That's the x-axis right there. So if I go across the x-axis, My point C is going to be 1 unit down. So it's going to end up being about right here. And we'll call that C prime. My point A is 7 units up from -2. So at -2, I'm going to go 7 units down. So instead of 7 units up, okay, I'm going to go 7 units down. So 1, 2, 3, 4, 5, 6, 7. So this is going to be where my new point A is. That's my A prime. And point B is 8 units up from -5. So instead of going up 8, we're going to go down 8. So 1, 2, 3, 4, 5, 6, 7, and 8 would be about right. That's going to be my B prime. Okay. And this is my A. Sorry, can't even draw straight. A to B, B to C. So that's part A right there. Now rotate A prime, B prime, C prime 180 degrees about the origin, which is at 0, 0, to form a new triangle, A double prime, B double prime, C double prime. Name this triangle, name the, okay, and the vertex. So if I go across the origin, I can use the hook method. So remember, so if I'm doing, to get my C, if I'm going 3 to the left and down 1, right, then 180 degrees would be 3 to the right and up 1. And that would be my new point C prime prime. Okay. All I did was just took this and rotate that's 180 degrees. And it went this way now. Okay. Okay, so that's called the hook method. I don't know if I mentioned that before. A prime, right? So if I look at that, it's going to be 2 to the left and then down 7. Right. So my hook method, I'm going to rotate that.
Track sprinters, if you're in track and you are a sprinter, head to the weight room at this time. Track sprinters, head on
2
over
to
to
the
the
right,
weight room.
and then
That's 100,
up 7.
Sprinters. Make sure to pick up your snack at the second lunch window. Glass Painting Club and Folklorico Club are canceled for today. The weight room is open for all students until 5:30. The library, we have Gaming Club, Chess Club, Lego Club, Virtual Reality Club, and 3D Printing Club. The library is open for all students until 6:15. Light buses, there is a 4:45 and 6 o'clock
B prime.
bus.
Let's see. We are going
Happy
5,
Valentine's Day to all.
5, and then down 8. Right, so that's my hook right there. So if I rotate this 180 degrees, it's going to be to the right 5 and then up 8. And that's going to give me my B prime. Prime. Okay. All right, so that's my triangle right there. So A to B prime prime, B prime prime to C prime prime, and C prime prime back to A prime prime. So that's it. Part B right there. That's if I rotate this 180 degrees. Oops. Let's call that B. And C, describe a single transformation that will map triangle ABC to triangle A double prime, B double prime, C double prime. Right, and you can see that this looks like, from the get-go, it looks like if I just did a reflection across this middle line, I would get that. All right, so it looks like if I just go, you know, 3 this way versus 3 that way, 2 this way versus 2 that way, 5 that way versus 5 this way. So it looks like I'm just doing a reflection across the y-axis. So part C, I would say reflection of triangle ABC across the y-axis. Okay, that's it. All right, hopefully that helps. We will continue tomorrow.